Good day, we are Group 1, and this is a podcast to demonstrate and examine one method of improving the efficiency of a shaped flashlight. The aim of this project is to investigate how the use of additional coils affects the electric field strength. Now let us look a bit into the operation of the shaped flashlight. The electromechanical energy converter, the magnet, converts the kinetic energy into electrical energy as it is moving through the coil. Now, how does a multiple coil configuration affect the EMF generated? An experiment was performed using a Java-based Faraday's electromagnetic simulator. It can be seen that as soon as the magnet leaves and enters the coil, there is a spike in voltage indicated by the light intensity of the bulb. Imagine capturing these peaks by having multiple coil configurations. Will this allow for a greater collective EMF and hence a greater current to charge the capacitor? But one thought is, how many coils is enough? This idea will be explored. The conceptual theory behind these objectives is Faraday's law of electromagnetic induction, more specifically, motional EMF. If we examine the equation, the EMF is generated due to the magnet moving through the coil, and it is dependent on the flux and number of turns. Zooming into this project, it is seen that the voltage induced is done by means of a moving loop with a time-varying area component. Now, how can we use this theory studied into a practical perspective? Well, a 2D model of the system was formulated in COMSOL using the AC/DC module. This was done since the linear generator possesses an axisymmetric geometry above the z-axis. The magnet is shown here, and the coil is shown here. A contour image was also produced to highlight the variation of flux density over time. The color scheme shows that the red represents the strongest flux, while the blue is the weakest. So these characteristics were then exported into MATLAB to show the results. So this graph illustrates the relationship of the voltage induced for each coil configuration of the 5-coil configuration. The red line indicates 2100 turns, the dark blue 1050, the green 700, the light blue 525, and the black 420. It can be seen that for the one coil with the largest number of turns allowed for the greatest EMF to be generated. That is the red line. Now, what will happen when we look at the collective arrangement of coils in the configuration? Well, we examine the voltage time graphs for each configuration as seen here. The red line represents the resultant voltage, the blue line represents the individual coil voltage, and the green line is the resultant RMS voltage. We will compare all of these graphs now, and it is seen that even though the one coil configuration had the greatest EMF voltage per coil configuration, it had the lowest EMF for the total coil configuration. It can be seen also that as the number of coils increases, the resultant EMF generated is also increasing. But will this trend continue to occur? Does adding more coils allow for a further increase of voltage? Now, in order to evaluate this concept, the resultant voltage for each configuration was plotted on one graph. It is seen that as the number of coils increases, there is an increase in EMF. However, the graph is beginning to plateau. This gives an indication that there is a nonlinear relationship involved. So we talked a bit about the results. Now let us move on into explaining why we got what we got. Now we notice that as the number of coils increases, the EMF also increases. This was due to the scalar addition of the EMF induced in each coil. However, we notice that there was a point where if you increase the coils further, it was beginning to plateau. This is due to the smaller change in the RMS voltage occurring. Now, some limitations for this project was that the entire coil configuration of the flashlight could not be designed into COMSOL. As such, one coil for each configuration was done. This was achieved by adjusting the number of turns in COMSOL. It is then manipulated in MATLAB accordingly so that we can have the constant 2100 gains. So to conclude, the objective of this project was completed, and the results obtained were that the RMS voltage increases as the number of coils increases. However, a non-linear relationship was seen since a plateau of the RMS voltage was noted as the coil number approached a 5-coil configuration. Thank you for your time.